Hi, welcome to Con 303. My name is Akshay Ram. I'm a product manager with AWS Fargate. Today we're going to talk about Amazon EKS with AWS Fargate Deep Dive. I'm super excited to talk about Fargate and the intersection of Fargate and Kubernetes. So let's get started. So the agenda for today is we're going to talk about how you use Fargate with EKS and the benefits of using the serverless operational model with the Kubernetes API. We're going to talk about some of the key features we've launched. And we're also going to take a little bit of a look at the roadmap and what's coming ahead. So let's get started again. With Amazon EKS, you have three compute options. The first is Amazon EC2 instances that you own and manage. So if you say, hey Amazon EKS, run a container for me, what we do is we run them in pods or services in your account. And also the instances are in your account and you have full control over them. So operated in this way, you have control over both the applications as well as the underlying infrastructure in the form of virtual machines. And a lot of customers like to run this way where they have full control over both the applications and the infrastructure. The second compute option you have is managed node groups. So you can say, hey, I want to run a container on managed node groups. We run this container as services or pods in your account. And the instances also live in your account. However, there's an added benefit here. Amazon EKS actually shares some of the heavy lifting of the virtual machines with you, like the patching of the upgrades of the army. And you get the added benefit of offloading some of the heavy lifting to AWS. So operated in this way with managed node groups, you have control over your applications, you have control over your infrastructure, and AWS helps you in some of the operational heavy lifting that comes with virtual machines. Finally, the third option, Fargate. You want to say, hey, run a container on Fargate. What we do is we run them on compute, which is fully managed by AWS. And what that means is it's serverless for you. You don't see any virtual machines in your account. It's completely serverless. And you operate it in this way on Fargate. You get control over the applications. And you don't have control over the infrastructure because it's fully managed for you by AWS. We see a lot of customers use EKS on EC2, EKS with managed node groups and Fargate. It's not an or either decision, it's usually an and, so there's a mix. But since this presentation is focused on Fargate, I'm just going to deep dive on Fargate. And so let's take a look on how you use Fargate with EKS today. The Fargate profile is one of the primary interfaces you'd use to operate Fargate with EKS. You have two specific knobs. The first is a knob that helps you select the kind of pods you want to run on Fargate. It gives you full control over specific sets of pods via namespaces or labels. The second is information such as subnets or IAM roles. And both of these give you enough information to say, hey, I want to spread my pods across multiple availability zones, or I want to give AWS certain permissions to do some housekeeping work on my behalf, such as downloading images or pushing logs. And that's full control you have. And the second part of the Fargate interface is something which is under the hood. It's not something you directly control. It's just the Fargate scheduler. And that's an under the hood implementation detail. But in the spirit of a deep dive, I want to talk about this, and we'll reference it in subsequent slides, and how you can use it as a customer, or rather you don't use it as a customer, but how it works under the hood to actually schedule your pods onto Fargate. And we'll see this in a subsequent slide. But let's take a look at the Fargate profile in more detail. Let's put some code behind everything I said. So this is the Fargate profile, and I'm going to highlight three key sections. The first is the selector. So this selector gives you full control over the kind of pods you want to run on Fargate. For instance, you want to say, hey, I want to run my web applications, my data analytics applications. And so those applications belong to some namespaces. So you want to add those namespaces of those applications here so they get scheduled onto Fargate. You get to add availability zones in the form of subnets. So you want to spread your pods across multiple availability zones for highly available infrastructure. And that's something you can do by spreading multiple subnets and giving us multiple subnets to place your pods. And you have the IAM role. And the IAM role is used by Fargate on actually the kubelet to do some housekeeping permissions, such as downloading a container image from Amazon ECR or pushing logs to CloudWatch logs. So given this is the Fargate profile works this way, let's try to see and how this all comes together. The first is, let's say you have a pod. Let's say your application team has a pod spec. And the pod spec is of namespace prod, and it has a label blue associated to it. What we do behind the scenes is we see, does it match the Fargate profile? Does it match a selector in the Fargate profile? And in this case, it does. We then inject the pod using a mutating or validating webhook saying, hey, this pod should be redirected to the Fargate scheduler because it matches the selector in the Fargate profile. And the Fargate scheduler comes in here. We spoke about this a few slides ago. And it's a standard add-on extension to the Kubernetes scheduler. And it looks for pods that have instructions to be run and scheduled on Fargate. And its job is to read that instructions and schedule them on Fargate. And what it does is, in this case, the pod has instructions to run on Fargate. It directly runs it on Fargate. And boom, at this point, you're running on serverless compute, and your pods are running on serverless compute, so you get the benefits of serverless compute. We spoke about the benefits of serverless compute. Let's actually see what exactly these benefits are. The first, you'll hear me say this a lot, is applications and not infrastructure. We really want on Fargate to help our customers focus on those higher order bits of business logic and not care much of the underlying infrastructure. And that's something we're constantly striving to improve as a team. And that's one of the benefits you get on operating on Fargate. The second is you don't have to scale clusters of instances for events such as peak scaling and scale out. Cluster auto scaling is fully managed by AWS. The third is all the host and container runtime patching. These are operations that would take up some of your valuable time. You don't have to do with Fargate because it's fully managed at this point. It's not something you control. Then you have pod isolation. Every Fargate pod runs in its own virtual machine boundary, which means it gets its own kernel, vCPU, memory, network interface, and storage. And this means you get built-in defense in depth. It's a nice security feature. And for use cases like multi-tenancy, it come in handy. And finally, you get streamlined updates because a lot of the software or the underlying infrastructure is managed by AWS. Whenever you update your Kubernetes cluster, it should be a lot more streamlined. You just relaunch your pod and it should all just work. So this is the benefits you get with serverless compute in the Kubernetes API, something which I'm super excited about. And I hope you see some of the value in this as a customer. So now that we've seen the value proposition of Fargate, let's take a look at some of the key feature launches. These are the three ones I want to highlight because I'm going to dive into some of them in detail. The first is support for Amazon EFS. A lot of our customers wanted to push the kind of applications that they can run on Fargate, and one of the application types was stateful applications that need a network file system. These can be applications such as content management systems or applications like data analytics that share data sets across multiple pods. So that's support which we launched. The second is built-in logging. Previously logging was slightly hard for customers. This is a feature we actually launched at re:Invent. Logging involved installing a sidecar and maintaining and managing it. What we did was we made it a feature of Fargate, so it's built into Fargate. You just tell us where you want your logs to go, and the rest is history. The third is network load balancer support. A lot of our customers run applications such as game servers or telemetry connectors that need layer 4 load balancing as they use UDP. And that's another capability we added. Before I dive into some of these features in detail, I want to take a step back and actually highlight a constraint. DaemonSets don't work on Fargate. Why is it pertinent to these features, you may ask? And they usually, for stateful applications as well as logging, DaemonSets is an important starting point in your configuration of your Kubernetes clusters, where you install the CSI driver, which is container storage interface, or a Fluentd driver across the clusters or virtual machines you own. But DaemonSets don't work on Fargate because one of the features of Fargate is you get pod level isolation, where every pod is isolated in its own virtual machine boundary. And by nature, DaemonSets need two pods to belong in the same VM. So this is a constraint we had to work around. And we actually sought a lot of customer feedback. And we came up with two design tenets as we designed some of these features. And these are, first, consistency where it matters. We really understand Kubernetes customers run across a variety of environments and at AWS. So they're coming from EC2, they come into Fargate, they work operating self-managed Kubernetes, they're operating Amazon EKS. So there's a lot of heterogeneity in environment, and they've built up a lot of operational muscle with Kubernetes. And this is something which we really wanted to respect and use as many native Kubernetes objects as possible while designing our features and capabilities. And the second is, hey, we're serverless compute. How can we simplify things for customers? We're always, as I said, looking for ways to simplify things for customers by managing more infrastructure or add-ons on the behalf of customers. So to actually design these features, we modeled our experience around virtual machines because this is where we knew our customers are coming from. So for EFS, we closely looked at the EFS experience with EKS on EC2 because we knew this is the entry point or this is the learning, this is the place where most customers have learned, and this is where they're coming from to Fargate. So it actually comes down to 5 steps of setting up EFS on EKS on EC2. The first is the administrator sets up creates a persistent volume. Usually this requires a step before this is like going to the AWS console, creating the EFS volume and coming with the volume handle, as you see, which is the file system ID. And you create this persistent volume and apply it to your Kubernetes cluster. The second is you install a daemon set across all the clusters of instances you own and manage. And in this case, it's the CSI EFS daemon set, which is installed on your instances. The third is the persistent volume claim. This is where your developers are going to say that, hey, I have a content management system. It needs 5 GB of network file system, and this is my persistent volume claim. Finally, there's the pod spec, where the pod spec references the persistent volume claim. This can be the actual application, which is the content management or the data analytics application. And the pod is scheduled on your worker nodes that you own and manage. So we took this experience and we really laid it out, and we came up with 3 personas. The first is the Kubernetes administrator. They operate with a lot of AWS objects and Kubernetes objects, and they set up the file systems and they create the persistent volumes in the storage classes. So those were concerns or objects or interfaces that they're really familiar with. The second persona is the Kubernetes user or developer, and they just want to run applications. They want to claim storage and run their applications and be done with it. And finally, the third persona here is Fargate. How can we enter and simplify things for customers? Can we take the CSI driver here and fully bake it into our infrastructure to simplify things for customers? And that's exactly what we did. We actually took the CSI driver and made it as a part of the Fargate data plane. So it's fully managed for you. You don't see or interact with it. It's completely now a feature of Fargate. And given that, let's see how the EKS on Fargate experience for configuring EFS is. The first step is the persistent volume claim. This remains as is on EKS on EC2, EKS on Fargate. It's just a very consistent experience. The second step is actually no step. You don't need to install a daemon set of the CSI driver. It's completely built into Fargate. So it's a step you actually skip. The third is the developer request for storage, and in this case, it's 5 GB. And this is the same experience as they would on EC2, because the developer really doesn't care if they're running on EKS on EC2 or EKS on Fargate. It should just work. And finally, the pod spec, which references the persistent volume claim. This also remains the same. Nothing changes here. And the pod is scheduled onto Fargate. So very similar experience, and this is how it works. So let's take a step back and see how it ties back into some of the design tenets we laid out for us before. The rows to focus on in this table are rows 1 and 4. This is where there's a diff between the EC2 and the Fargate experience. For instance, on Fargate, the CSI driver is built in. And what this means is you not only get a simpler provisioning experience where you have a step less while provisioning your clusters. You see, the CSI driver is also software which has its own life cycle, and it has some management of it, and that's something you completely skip. So you get simplified day 2 operations also on Fargate. And rows 2 and 3 says you get the same consistent interfaces across both EC2 and Fargate in terms of the Kubernetes objects you're familiar with. So what are the takeaways? Applications are not infrastructure. The CSI driver is built in, it's infrastructure components, so those bits are built in, so you focus on the higher order bits, which is your business logic. You get the same consistent Kubernetes objects you use, so your switching cost is minimized. And then finally, you also get a lot of capabilities. This is something you'll hear me say a lot, as customers are really pushing Fargate to add more capabilities in terms of the number of application types it supports. So it now supports applications that need persistent storage, be it content management systems or data analytics systems, which need data sets to be shared across multiple pods. The second feature was logging. Same case here, it was usually done through a daemon set. So we really wanted to study the logging on EKS on EC2 experience, because we knew this is where customers are coming from. Logging is slightly more simplified. There's only 3 steps here. The first is applying a config map to your Kubernetes cluster. This config map has fluent configuration as a part of the value in the key value pair. And fluent configuration is fluent D configuration. It's basically a configuration language for fluent D, which is a CNCF project. It's commonly used with Kubernetes. It's quite a concomitant add-on for logging in Kubernetes. The second step is you actually install the daemon set, in this case, the fluent D CloudWatch daemon set, and apply it to your, and make sure you install that driver across the instances you own and manage. The third is the application developer just has a pod spec and they just want logging to work. To them, logging is a fundamental primitive. It's just part of operating an application. They just want it to work. And the pod is scheduled on to EC2 instances that you own and manage. So given this is where customers are coming from, we wanted to again understand the lay of the land and map it through our 3 personas. The Kubernetes administrator, in this case, cares about the config map and the fluent conf. This is languages that these are languages or objects that they are fluent with. Then there's the Kubernetes user who cares about the pod spec. At this point, they just want logging to work. It's not something that they think it's a fundamental primitive. They don't want to change their application code to write files to a separate location, to a disk. They just want logging to work. And finally, Fargate. In this case, can we take the fluent bit driver or the fluent T driver and build it into the data plane such that it's a feature of Fargate? And that's exactly what we did. This is a feature, as I said, which launched at reInvent. We used fluent bit over fluent D because fluent bit is written in C, unlike fluent D, which is in Ruby, and it's lighter weight and a lesser surface area. And it's built into the data plane. So we worked with the fluent bit community to contribute certain plugins. And we're always looking to expand that open source project so you as a customer get more selection of communities that comes along with fluent bit. So given this, let's see your experience with EKS on Fargate and your logging experience. You start with the config map. The step 1 remains the same. As I said, I want to keep things consistent, and that's what customers told us across EKS on EC2 and EKS on Fargate. Your config map remains as is. Your fluent conf remains as is. You're fluent with these languages, just remains as is. The second step is the daemon set. It's completely now baked into the Fargate data plane, so you can skip this step. The third is the pod spec. The pod spec is nothing changes. Developers want their logging to work. They don't care if they're running on EC2 or Fargate. It should all just work. And the pod gets scheduled onto Fargate. So again, tying this back to some of our design constraints which we had set for us in the beginning. Again, rows 1 and 4 are of importance because there's a diff between the EC2 and the Fargate experience. Diff in the form of simplicity. It's a simpler step in that you don't have to provision or install the daemon set, as well as you don't have to maintain or manage the lifecycle of the fluent bit add-on, which is software which you have to own, and so you don't have to care about that anymore. It's fully managed. And rows 2 and 3 also say that, hey, you have consistency and you have that consistency across compute types, which is really important for our Kubernetes customers. Takeaways here. Again, applications on infrastructure, fluent bit is now baked in. It's some more infrastructure components that are managed for you so you can focus on those higher order application bits. You get consistency in the Kubernetes objects. That's something I've spoken about a lot, and you must have seen in the previous slides as well. And the third is, again, capabilities. This is super important. You get to send your logs to Amazon CloudWatch, Kinesis Firehose, Kinesis Streams, Amazon Elasticsearch. We're also working on enabling more output plugins in the months to come by working with the Fluent Bit community and contributing and enabling the plugins on the EKS side of things as well. The third feature, which was significant, was network load balancing support. Network load balancing support is something that runs outside the pod. I mean, it doesn't run in the data plane or the compute level. It runs outside. It's usually the network load balancer sit in front of your applications. And what this means is you get a super consistent experience across EKS on EC2 and EKS on Fargate. And let's take a look at how that experience is. We really wanted to simplify it for our customers. And let's take a look at it. You want to run a network load balance service on Fargate. What we do is behind the scenes, we run that service on compute, which is fully managed by AWS. And we also took it a step ahead saying, hey, can we just provision network load balancers on your behalf? And it becomes super simple for you because you don't have to worry about network load balancing. You just want to run a game server and network load balancers are provisioned. And that's exactly what we did. We provisioned the network load balancer on your behalf. So the experience is super Kubernetes native, super friendly. It should be pretty easy to do. And this is possible by a feature we launched called the AWS Load Balancer Controller, which you apply to your Kubernetes clusters. And it works across EKS on EC2 as well as EKS on Fargate. This is how you configure it. Very simple. You just annotate your pods with saying, hey, I want to use NLB, a load balancer, and I want to use NLB with IP targets. And the NLB is directly provisioned on your behalf. And the experience is really simple. Tying this to your design constraints, which we laid out earlier, is you get consistency across both EC2 and Fargate. You just have to apply the AWS Load Balancer Controller. And you just have to annotate your services, and the NLB is provisioned on your behalf. There were a few other notable feature launches which I want to point out. The first is we launched EKS Fargate Compute Savings Plan support. Compute Savings Plan support gives you up to 50% off on your Fargate usage. So if you have applications that are running consistently, that are always processing data, you get to leverage the discounts. And the nice thing about Compute Savings Plan is they're transferable across compute options at AWS. So if you're running EC2, Fargate, or even Lambda as you modernize your applications, you get that savings. So wherever your usage goes, your savings follow. The second is we are always looking to expand EKS Fargate support to multiple regions. We are in 18 regions. We plan to launch in multiple more regions. That's something which you can expect us to continue that expansion going forward. The third is ephemeral storage on Fargate. So on every EKS pod that runs on Fargate comes with 20 gigabytes of ephemeral storage. We now encrypted that volume with a service managed key. So it's useful for applications that are compliance sensitive. And that's a feature you get by default. No customer action needed. Given all these features and capabilities, I also want to highlight certain limitations that come with operating in Fargate. The first is there's no privileged pods allowed on Fargate. We have blocked full privileged access or adding any Linux capabilities. And privileged usually need a lot of Linux capabilities to run. So use cases like Docker and other such use cases that need privileged pod do not work on Fargate. So it's a limitation you should be aware of. The second one is there's no general support for DaemonSets, as I laid out earlier in this presentation. It is something we're thinking about to simplify for our customers because there's going to be some switching costs when you're installing a Helm chart which uses a DaemonSet across EC2 and Fargate. There's going to be a little bit of a switching cost involved. So we're always going to see how we're going to simplify that experience for our customers. But it is a limitation you should be aware today as a customer. The third is there's no GPU support. So if you have heavy machine learning applications that need graphics acceleration, you don't have GPU support on Fargate today. And the last is there's no Amazon EBS support. So if you have applications that need persistent storage and that can't don't need the price performance of EFS, but rather the price performance of EBS, that's something which doesn't work on Fargate today. But I want to call back to something which we revisited earlier, given that there are some limitations, is the selector. The selector helps you say, hey, I have pods that need privileged modes. I have pods that need GPUs. You just don't match them in your Fargate profile. You match the pods that don't need privileged mode or that don't need machine learning or don't need EBS support. And what we do is behind the scenes, every EKS cluster is a mixed cluster, and we see this pattern a lot. So you can operate your machine learning pods on EKS on EC2, EKS on managed node groups, and you can run the rest on Fargate. And this, as I said, it's never either an or decision. It's usually an and we see customers operate across a variety of compute options with Amazon EKS. Given that, let's take a look at what's coming ahead for our customers. The first is we're launching built-in metric support. Just as we did with logging, we launched the Amazon distro for OpenTelemetry. And we want to build that into Fargate so you get built-in metrics and tracing support, just as you do with logging. It's a common ask from many of our customers. We want to expand the ephemeral volume that comes with Fargate. So a common pattern we see on Fargate are data analytics applications that download and process a lot of data from S3. So they need more than the 20 gigabyte that comes by default. They want up to a few terabytes, some of our customers. So you will be able to expand that in an upcoming release. The third is network access control for your pods via security groups. That's a feature which we're going to add as well. And finally, we're always looking to expand our partner support on both container runtime security, logging, monitoring metrics. We really want that community support, and we're working with projects like FluentBit, OpenTelemetry to really enable that community support for our customers, which is really important. You can get started today. It's just a simple, this is the EKS CTL tool. You can just create a cluster and say --Fargate, and you should be able to get started. And I'm super excited to see what you can build with Fargate and how you can use Kubernetes and Fargate. And I'm excited to see what you build. Thank you very much. I hope you saw value from this presentation, and I look forward to your feedback. Please don't forget to leave feedback on this session. Thank you.